So here's our first example. We are going to find an orthonormal basis in R3. So now we're first going to rely on knowing how to find any old basis in R3. Now this one says that there's a given vector that should be included in the basis, or at least the unit vector in that direction should be included, that vector 1, 2, -1. We'll normalize that, and that will be our first Q1 hat. So we're basically finding two other vectors in R3 that will be orthogonal to this given vector of 1, 2, -1. So now we are counting on knowing already how to find a basis of R3. A good way to go is to use that standard basis, the 1, 0, 0 and the 0, 1, 0. So now pause this video and go study some chapter 2 stuff if you want to figure out how to get those first three vectors, just the normal basis, the regular any old basis of R3. The last thing on page 4 is we are in advance laying out the organization for this problem. Remember, stressing multiple times on video recording that the organization is the key. So that whiteboard that I held up during the organization, you can see this is the 3D version of that. There's the original A matrix, that's the original basis. The columns of A are the basis vectors. We are going to find the columns of Q. That's the Q1 hat, Q2 hat, Q3 hat. And those will be the columns. And then R is upper triangular. And we already know what's going to go in all of those things. Now it's just a matter of in what order do we compute these things in order to get the job done. So now that order is we're going to go through a sequence of steps on page 5, like when we turn the page, and we're going to basically do it one column at a time. So I've already outlined we're going to find Q1 hat by taking our given vector 1, 2, -1, and we are going to normalize it, meaning we're going to find the norm and we're going to divide every entry by that norm. It's like scaling out 1 over the norm.